Hey everyone, I'm Mr. Simon, and today we're gonna be going over matrices, addition, matrix multiplication, etc. So before we start, I kind of want to just highlight the objectives for today. So, objectives. So the first thing I want to cover is what a matrix is. What is a matrix? Okay. The next thing we'll cover is matrix addition. And then we'll talk about multiplication by scalars. And then at the end, we'll kind of go over matrix multiplication. All right, so can anyone tell me what a matrix is? What is a matrix? Anyone? Yeah, Fred. Yeah, good, right. So the way I want to define a matrix is like what you said. Let's just keep it simple. A matrix essentially is just a table of numbers. Okay? So what do I mean by this? Exactly what it sounds like, right? So let's give you an example, okay? Let's say we have matrix A, okay? Matrix A could look something like this. 7, 2, 3, -5, 0, 1, okay? So that's what a matrix is. We have a table of values, and in each place we have a number, okay? So quickly, let's define what the order of this matrix is. So the matrix order. Okay, so this matrix here, we will call it a 2 by 3 matrix, okay? What is a 2 by 3 matrix? 2 meaning the number of rows, and 3, you guessed it, the number of columns, okay? And this can be generalized, and you'll see this as you go through problems. It's generalized as m by n, okay? So we have a matrix A, its order is 2 by 3 because it has 2 rows and 3 columns, okay? Does anyone have questions about that? Okay. So let's go ahead and we're going to let A sub ij represent the number in the ith row and jth column of matrix A. Okay? So what do I mean by this? Let's do an example. Let's say I was asking for A1, 3. Okay, what does that mean? That means we're looking for the number in the first row and the third column of matrix A, right? So we go the first row, we go the third column, and we see a 3 there. So A1, 3 would be 3. Right? And why don't you guys try A2, 2? Not too bad. Does anyone want to represent? Yes, 0. Awesome. Okay. So at this point you might be saying, okay, well that's nice. You can put a bunch of numbers in a table and assign all this fancy, numbers, fancy notations for all this, but what's it good for? And honestly, that's the interesting point. Is that's really all matrices are. They're just a way to represent data, and it's just a way to write down data, right? But it has a wide variety of applications, and as you'll see in further math classes, I mean, the ways you can use matrices are endless. In algebra, you'll actually be doing this at one point. You can use matrices to represent linear equations and solve systems of linear equations. Another application is in computer graphics. So elements can be represented as pixels on a screen, and you can encode a video game where every entry represents the color of the pixel in a video game or something like that. So to summarize, a matrix is really just a way to represent a set of values. Okay, does anyone have any questions on that? Okay, so now we're gonna briefly talk about the formal way to denote matrices. Okay, so to represent matrices, representation of matrices. Okay. All right. So there's three ways that we can represent a matrix. Okay. The first way is via an uppercase letter. Okay. So A, B, etc. Okay. Another way we can represent matrices is by what we call a representative element enclosed in brackets. Okay, so this would look something like A sub ij. So A sub ij is a representative element in matrix A, and when we put the brackets around it, that is the same way as saying matrix A. Okay, and lastly, what we talked about before, a rectangular array of numbers. Okay, so this would look like, up here would be A11, A12, etc., up to A1n, A21, A22, up to A2n, and so on, all the way down to AM1, AM2, all the way to AMN. Okay? And like I said, we can represent that as a rectangular array of numbers. It would be the same thing as saying matrix A, or it would be the same thing as saying matrix A sub ij. All are appropriate ways to represent matrices. Does anyone have any questions on that? Okay, let's move on. All right, so let's talk about matrix addition. Okay, how do we add matrices? All right, so the sum of two matrices of the same order, okay, that's important, of the same order, m by n, can be found by adding their corresponding entries. Okay? So the sum of two matrices of the same order m by n can be found by adding their corresponding entries. Okay? Also, the sum of two matrices of different orders is undefined. Okay, so if I give you a 2 by 2 matrix and ask you to add it to a 2 by 3 matrix, it's not actually possible to do that, and we say that the sum is undefined. Okay, so what I'm going to ask you guys to do now is I'm just going to write some matrices on the board up here, and I want you guys to partner up with whoever's sitting next to you. So these two rows partner up, these two rows partner up, And with your partner, just kind of work through these examples, okay? So let's say I said matrix A, okay? So I'll write them on the board and go ahead and get started copying them down. All right, I'll give you a few minutes. Okay. All right. Does anyone want to tell me what they got for number 1? A plus B, right. 8, 4, 6, -1, 5, 7. Good, right? And how did you get that? Well, you added, the corresponding entries. So 7 plus 1 was 8, 2 plus 2 was 4, etc. What about A plus C? Yes? Good. Undefined. Right? We have a 2 by 3 matrix and we're trying to add it to a 1 by 2 matrix. We can't do that. That is undefined. Anyone have any questions on matrix addition? Great. Okay. So now what I want to talk about is multiplication by scalars. Okay, so who knows what I mean by a scalar? Can anyone tell me? A number. Exactly, right? So when we're talking about matrices, numbers are referred to as scalars, and they can really refer to any real number. 7, 10, pi, etc. Okay, so how do we multiply by scalars? So the scalar multiple of matrix A by the scalar C, and we use a lowercase letters when we're talking about scalars, is found by multiplying each entry in A by C. Okay, so what do I mean by that? Let's say let's do an example. We'll do this one together, right? So let's say I have 3 times matrix. This is from the previous example, 7, 2, 3, -5, 0, 1. Okay, so how would this is the same thing as saying 3A, assuming that's matrix A. How would I do this? Right, so I would just multiply each entry by 3. So 7 times 3 is 21, 3 times 2 is 6, etc. Great. Okay. So let's go over some important properties. Okay, so properties of matrix addition and okay. So there's 6 important properties to know. Okay, so the first is that if I have matrix A and B, assuming they can add together, assuming they're the same order, I can also do it as B plus A. Okay. All right. Does anyone know what this property would be called? Think back to elementary days with, right, yes, commutative property, right? So we'll call this the commutative property of matrix addition. Good, okay? The next thing you should be familiar with is that if we add B and C, A plus B plus C is equal to A plus B plus C, okay? So if we have three matrices being added together, it doesn't matter what order we add them. We can add B and C and then add that to A, or we can add A and B and then add that to C. Does anyone know what that would be called? Right, associative. Associative property of matrix addition. Okay? The next one. Let's say we have two scalars, okay, C and D. All right, so C and D equals. And so that's equal to C D times A. Okay? C D times A. So what this is saying is if we have two scalars, we can multiply the scalars together and then multiply the matrix by that new scalar. Or we can multiply one scalar into the matrix and then another scalar in the matrix. That's equivalent. Okay? What do we call that? Again, associative property of, and this is scalar multiplication. Okay? The next one is going to seem a little silly, but it's important when you get into more vector calculus and vector spaces. You probably haven't heard those terms, but this is important to know, and that's that multiplying any matrix by 1 will get you the original matrix, and we call that the scalar identity. Okay? And lastly, I'm going to break this up into 5A and 5B. So C times matrix A plus B, so C is a scalar, is equal to CA plus CB. So if I have a scalar multiplied into the addition of two matrices, I can add the matrices and multiply by the scalar, or I can multiply the scalar into A, multiply the scalar into B, and then add it. Does anyone have any idea what that would be called? Right, the distributive property. Distributive property. Okay. And 5B is going to be similar, but now instead of two matrices, we're going to have two scalars. So C plus D times A is equal to CA plus CD. Okay, and that's going to be called the same thing. Does anyone have any questions on that? Okay. Let's say, all right. Okay, so now what I want to do is I want to take a little detour, okay? And before we go ahead and talk about matrix multiplication, I want to talk about something called the dot product, which I think you may have mentioned in class before, but you haven't formally defined it. So that's what I want to do. So let's take a little detour to the dot product. Okay? So let's say I have two matrices, okay? I'm sorry. Let's say I have two vectors. Okay, so vector A will be A1, A2, A3. And let's say vector, you know what? Hold on 1 second. Okay. Let's say, vectors can technically have as many elements as we want. So let's just say it goes up to AN, okay? And then let's say we have a vector B, and that's equal to B1, B2, B3, all the way to Bn, okay? Then we say that the dot product is, okay, So A, and we represent this mathematically as A and B with a dot in the middle, okay? And that's equal to A1, B1 plus A2, B2 plus A3, B3, and we're going to do that all the way up to the last term in the vector, which would be AN, BN, okay? So this here is the dot product. So what I'm doing is I'm taking the first two numbers in the vector, adding them, multiplying them together, adding that to the next two multiplied together, so on and so forth, okay? And something that's important to note is in the dot product we start with two vectors, but our actual answer for the dot product is not a vector, it is what? It's a scalar, right? So note that it's a scalar, okay? So let's just do a quick example. So let's say matrix A is 2, 5, and we'll say matrix B will be -3, 1. Okay? So find A dotted with B. Okay? Does anyone want to take a stab at this? Yeah, so it's 2 times -3 plus 5 times 1, which equals -1. Okay, does anyone have any questions on that? Okay, so now we've defined the dot product, okay? Why did we do that? So you're actually going to see these dot products are going to pop up a lot in matrix multiplication, and it's essentially what you're doing in matrix multiplication, okay? So let's suppose we are trying to find matrix C such that AB equals C. Okay, so what I'm basically trying to say, sorry, A times B equals C. Okay, so what I'm trying to say is we're trying to find the result, the answer, the matrix you get when you multiply matrices A and B. Okay, so let's say we have matrix A. Okay, let's say 2, 1, 3, 4, and 5, 6. Okay, let's say we're trying to multiply that by matrix B. And we'll say it's 1, 3, 6, 2, 4, 5. Okay, so before we even start, right? So that's going to equal some matrix C. Okay, before we even start, okay. First of all, I want someone to tell me the order of these two matrices. Okay, the matrix order. So yes, what would matrix A be? Right, 3 by 2, right? 3 rows by 2 columns. And then what about matrix B? That's a 2 by 3 matrix, okay? All right, so the first thing that we need to do is we need to look at these two inner terms, okay? Okay, 2 and 2. Those numbers must be the same value to multiply, okay? So must be same to multiply, okay? So if those numbers are not the same, we can't multiply the matrices, it's over, undefined, okay? Now, in this case, they are the same, so we can multiply. And in that case, we take these two numbers, okay? And that is the new dimension of our matrix, of the matrix C that results from multiplying. So we know we're looking for a 3 by 3 matrix. Okay? Does anyone have questions on that? All right, let's keep going. Okay, so okay, let's say this. Okay, so any entry in C, so the resultant matrix we get when we multiply A and B. So any C sub ij, okay, any entry can be found by dotting, and by dotting I mean the dot product, right? Dotting the ith row in A by the jth column in B, okay? Now this might sound a little convoluted, but let's do an example to see what I mean by this, okay? So let's say I have matrix, we'll do a 2 by 2, okay? So 1, 2, 3, 4 multiplied by another 2 by 2 matrix, okay? So 5, 6, 7, 8, okay? So let's review what we need to do to multiply these, right? So we have a 2 by 2 matrix multiplied by a 2 by 2 matrix, okay? And so the first thing is we need to make sure these numbers are the same, which they are. So good, so we can multiply, okay? The next thing, because we can multiply, is we can take the outer numbers, and now we know we're dealing with a 2 by 2 matrix, and that will be our answer C, right? So I'm going to make space for a 2 by 2 matrix, and I'm going to leave a lot of room because you'll see why in a second, okay? So we have a 2 by 2 matrix. So let's talk about the first entry, which is in the top left. And remember, to find each entry, we dot the ith row in A by the jth column in B, okay? So what do I mean by that? So we're in the first column and first row of C, right? So this is C11, right? So we go to the first row of A and the second row of B, right? So 1, 2, 5, 7, and we dot those, okay? So we go 1 times 5 plus 2 times 7. Make sense? Okay. And then we do the same thing for this entry. So now we're in the first row, second column. So we go this first row of A, second column of B, and dot those, okay? So that would be 1 times 6 plus 2 times 8, okay? Same thing here. Second row, first column. So second row of A, first column of B, 3 times 5 plus 4 times 7, okay? And lastly down here, so we go second row, second column, so we have 3 times 6 plus 4 times 8, okay? And then you can simplify this down and you'll get 19, 22, 43, and 50, okay? Okay, so that was the big matrix I wrote there was just to show you guys the math behind it, but a lot of times you'll do the dot products in your head, and you don't need to necessarily show all that work. So matrices, multiplying them is very intensive, and you definitely have to be careful because you can make a lot of arithmetic mistakes. So what I'm going to do now is, what I want you guys to do is break up into groups of 3 or 4. I think your teacher said you already have groups, and I'm going to put up 5 problems that I want you guys to work on as a group, okay? So go ahead and break up in your groups and work on those, and I'll give you about 5 or 10 minutes, and I'm going to walk around while you're working on those. Okay. And now we're back. Okay. So at this point, okay. Let's erase that. Okay. All right, so let's talk about properties of matrix multiplication. Okay. So the first property, ABC is equal to ABC. Anyone want to take a stab at what this would be called? Right, associative property of matrix multiplication. Okay? The next one, okay, we'll call this 2A and 2B, because these ones are similar, right? So A, B plus C is equal to AB plus AC. Okay. We'll call this the left distributive property. And we also can say A plus B times C equals AC plus BC. We'll call that the right distributive property. Okay? And then the last one we'll go over is scalar C AB is equal to CA times B. Okay, so you can multiply a scalar. You can multiply two matrices and then multiply by the scalar, or you can multiply the scalar into one matrix and then take that and multiply it by the other matrix. Okay, and that is called the associative property of scalar multiplication. Okay. Important note. Okay. AB is not equal to BA. Okay. Remember, that's the commutative property. Back in addition, you can A plus B is the same thing as B plus A. When we're talking about matrices, this is not true most of the time. Okay. All right. Okay. Let's see. Now we're going to talk about one more thing. This is called the identity matrix. Okay? So let's define this, okay? So we'll call it the n by n, alright, which is a square. A square matrix that consists of ones on its main diagonal and zeros elsewhere. Okay? And that is called the identity matrix of order n. Okay, so for example, I3 would be equal to ones on the main diagonal and zeros elsewhere. Okay? Now this should look familiar because I think all of you got that challenge question, right? So what happens when you multiply a matrix by the identity matrix? Yes. Right, you get itself, right? So we say that AI is equal to A. Good. And in addition, you can actually multiply in both orders. So I times A would also be equal to A. So it does commute when we're talking about the identity matrix, but otherwise it does not. All right. Any questions?